Good morning. Exactly, it will be on soil grids, but a little bit in a different way. A small spoiler: I will only get to the soil grids and the spectral analysis at the very end of the presentation. So I'm Christophe and Neste. I work in Mai's Botanic Garden, actually, I'm quite new to the remote sensing and Earth observation fields. Just in the beginning of the year, I went to the Biospace conference, which for me was really a big introduction into it. And there it was really emphasized the importance of in situ data to be able to validate a lot of these models built on top of remote sensing. So what inspired me for this presentation is to really go into how we are collecting in situ data for a very specific purpose. So let me first delve a little bit into minerals from in the title and what I mean with it exactly. Of course, from a geological point of view, you have the minerals in the soils, and that includes silicates, oxides, carbonates. So a lot of soil grids actually deals with this as well. But from a consuming point of view, the big public might know minerals more in the sense of mineral water and the minerals that you find in the water, and that of course relates to the soil minerals as well. And then finally, you can also check on the foods that you're consuming, which kind of nutrient minerals are there, and it will be essential minerals like iron, zinc, selenium that we absorb through our diet. Now, the reason why this is of interest to us is related to EUDR, that we already had presentations by Robert, amongst others. So this is legislation. It was supposed to come into force last year, but they postponed it until this year. So from 2026, it will be required by law also to do scientific analysis to check if importers, exporters are respecting the EUDR regulations. So there shouldn't be any crops imported into Europe that come from deforested lands that are deforested after 2021. And we wanted to offer a service to deal with this from a scientific point of view by analyzing the crops and checking their minerals and relating that to their origins. So that's why this year we started the Crop Source Investigations Laboratory, and it's really from the ground up. So we just bought the machines the end of last year, which is a microwave digestion system, and an ICP-OS, that's inductively coupled plasma optical emission spectroscopy. So it's a long name. Basically what we do, we digest organic materials like coffee beans or cacao beans or timber in nitric acids, and then we make we dissolve that, of course, in mineral-free water, and then we can put this on this machine, which introduces into an argon plasma, and we get light signals for the minerals that are present. And that's what we actually want to relate with the origin, and that's, of course, while getting information from the minerals in the soil, in the origins, is also of very high importance to us. This project is not something I do just by myself. I actually started because I have a big interest into coffee, which was not what I was originally working at the garden, but this then gave me this opportunity to offer my knowledge as a coffee enthusiast and also coffee roaster for this project. But I do this really together with Victor de Klerk, who works for World Forest ID, that I know some of you already know, and he came from a background in tracking illegal wood trades. And so his first interest was really in timber, and so we kind of align our skills and interests to make this project work. So in the current presentation, the mineral will just be macro and micronutrients, including trace elements that allow us to get a fingerprint for the crops to be able to relate with their origin. But as this is really a new project for us, and new machines, we need to validate our machines before we can do the broad geological analysis. And to do that, I don't know by a show of hands, how many have ever watched a coffee YouTube movie? Nobody? One person? Wow, okay. So one person might then know James Hoffman, which for all the coffee geeks, he's very famous. He has like plus 2 million subscribers. But he's an interesting case study in the sense of, you know, he's really also a citizen scientist. He uses that amount of subscribers to basically do experiments. And one of those experiments is trying to taste the difference in decaffeinated coffees. Now, as a scientist, I was thinking, well, this is interesting because we're also not just relating the origins, we need to know what are all the factors impacting our analysis, the signature. What kind of processing? Because in the case of coffee, you have fermentation steps, you have washing steps, and you have things like decaffeination. So from where it's on the farm to where it's in your cup, there's all these steps, and what kind of processing steps influence the signature. Of course, the very last step where you make your coffee and you add a lot of water, I mean, it won't be very sensible to analyze that to relate to the origin, because as we know, most of your coffee drink is then actually water that you're getting locally. But so this was an opportunity. I got this set of decaffeinated coffees. The roastery Giraffe Roasters from the Netherlands was actually kind enough to also send me the original green beans, a small sample, so I could also see the processing step of roasting. So what's the difference between the green beans and the signal that we get in the roasted beans? So how does a mineral profile then look like? Well, so here we see just the green beans, the signal, and then the roasted, the signal. So just visually, you can already appreciate that they are quite similar. We'll go a little bit more into detail in the next slides. And here we have those decaffeination methods. So here we have the original caffeinated coffee. You can use carbon dioxide to extract caffeine. You can use ethyl acetate, which they get from sugarcane fermentations, and you can use Swiss water. This will turn out to be the most interesting in impacting actually the signal. So then what influences a profile, if we think about it, there is a geological factors like what are the soil minerals in the ground. You will have an impact of latitude and altitude actually on isotopes. So this work at the garden, we're just looking at the macro and micronutrients with this chemical analysis with the ICP-ORS, but we're also collaborating with Ghent University to look into isotopes. This is very important for the timber work that Victor has been working on, because the rain isotopes, there's a way of linking it to latitude and altitude, actually, the kind of isotopes you will find in the ground. So then what are the processing factors? The moist level, of course, that will give you kind of the amplitude of your signal. We learned in the last couple of months that we should also do dry weight measurements to be able to normalize. We will see that in the next slide as well. And then the pre-processing, the kind of fermentation that happens, the decaffeination, or maybe extractions, you know, if you extract olive oil. So olive oil is not a forest risk commodity, so it's not something that falls under EUDR, but it might also be something that you want to do food authentication on and things like this. So if you now compare this kind of green and roasted abundance, so you see that in general, the trend is that roasted will have just a little higher abundance of all the elements, which, I mean, makes perfect sense, because when you're roasting, you're evaporating the water. So just your dry weight is actually changing. But that might be a variability that we can account for by just measuring the moist content before we do this kind of analysis. So this was one small lesson already learned this year. And when I just calculated the median, it was actually 86% compared to the green beans, which would make sense if you take into account that in a medium roast you lose around 15 to 17% of your weight. But there is actually a lot of variability. So this kind of initial analysis allows us to see how consistent are these signals. But if you look, example, at calcium, here in the roasted one, that was the caffeinated one, it's actually less than in the green one, which isn't the trend we would be expecting. So this initial year is really, learning about all the variation that we have. Now, if we look at what was maybe transformed by a decaf method, there was this very huge difference with the Swiss water method, which 1,200% difference in aluminium. So, of course, it's important to know what actually happens in Swiss water. The idea behind Swiss water is that they iteratively enrich water with all the components that are in coffee, except caffeine. I mean, they will extract the caffeine from this water and then reuse the water. So what then happens is you introduce the beans in that water and just the caffeine moves out, right? That's the theory. But of course, they're using a water source in this, and they must be using something else that's giving us really a spike in aluminium, less so for the other kind of elements. So this is the kind of general work we will need to do in the future to analyze all these different kind of processing methods, see for which kind of elements we have spikes or big changes. So it doesn't mean that in general it would not be useful if the coffee was decaffeinated by the Swiss water, but you kind of need to know what to expect on the impact of your signal. So I actually wrote a mail to the Swiss Water Company, which, just as a side note, Swiss Water, that methodology was developed in Switzerland. That's why it's called Swiss Water. But a Canadian company bought those rights. So it's actually being performed in Canada, but they just didn't respond. I guess, I don't know. I would be interested if I got this kind of scientific input. So this kind of gives you already the background and how steps, from the farm to your cup of coffee can impact that, but it's not getting us the Earth observation analysis that this is about. But why I wanted to come to the workshop and why I'm actually very grateful in the past 2 days, I already learned a lot and opportunities to be able to link those two things together. Because at this point, I'm just, analyzing that variation in the processing, but I'm not really linking it yet with the origin. Now, in the past couple of years, I did, out of my personal hobby, already start to track coffees and tastes, with the ambition at some point of doing some geo-based analysis on that as well. So we're looking here at Perugia. Actually, this is just like, I think, 3 kilometers from here, Menchetti. I really love this place. I gave the coffee just a score of 67. I mean, I go for the pastries and the pizza. And in Italy, I'm very grateful to Italy. I actually started drinking coffee because of Italy. But they still like what they call an Italian roast, which is a little bit too dark for my personal taste. So it's quite objective. How am I time-wise? I'm still good? Yes. So I started kind of collecting this everywhere I'm going. I'm doing these kind of observations in the hope of then doing some broader analysis later. But actually, for this presentation, next to coffee, I did start analyzing some olive trees. This is actually the garden of my parents-in-law, where I sampled 3 olive trees and the leaves and the olives growing on them. I also got some from Perugia, from the university, actually from the botanic garden, where the person working there was so kind to allow me to do this kind of initial analysis. This also helps, again, to understand better the processing. I was drying the leaves of this garden a lot longer than I did of the other 2 locations I was sampling, and I could also see that in the eventual results. So again, a reason why I need to normalize that. This whole process, and this is why I wanted to share it, shows me how difficult it is to sample, to get these in situ data, to account for everything that might be influencing it. So it's important for you to realize, like at the baseline, when people are in the field collecting these things, it can go wrong at a lot of different moments, and it can impact the signal. And you need to do a lot of cleaning that then also possibly. So, of course, I want to, the whole point is in linking it to the origin. So the whole point for us is knowing what's the signal in the origin from which they are claiming that a certain forest risk commodity is coming from. So next to the lab work and analyzing the signal, I then need to relate it. And in the long term, the ambition, of course, what we do in Mice Botanic Garden is to build up this reference database, also, of course, together with World Forest ID. So we get this big new data set, new database that would allow us to check when somebody claims my forest risk commodity comes from that, we can relate it to models based on our data set, but this is a work in progress. So I wanted to cheat. I mean, I wanted to just use what's already available for my few samples. Can I already get some interpretable results just based on one sample, what data is out there? And I found that the last couple of months working on this presentation that it's not so easy. In general, there's possibilities like working with spectral bands and working together with co-pilots, everything you ask to co-pilot, it gives you. I don't trust it, but there's probably, it's using these bands that I don't know because I don't have the experience with it. So anybody that has tips on that, I'm very happy to hear, but it gives you a methodology to relate it to the iron content and quartz content and things like this. So it looks like I could, in theory, do something with it. And then, I could get this indicators for iron and the carbonates and the silicium for this kind of different locations. So if I then do an analysis on these olives, I can then relate it to what I would find through the remote sensing data. But I was a lot more excited on SoilDB. I mean, I was like, it does contain or potentially contain elements like phosphorus, potassium, magnesium, and actually the extractable variant, which is what's more relevant for us when we're analyzing crops. Extractable means it not just that it's in the ground, but that the plants can take it up. So we consider plants, crops to be proxies for the soil they're growing on. And then this graph, which I saw thanks to Tom's workshop, I love it. I could just, it's perfect for my needs. I haven't been able to use it yet because I learned about it just during the workshop, but I now know there's the API. So I'm all set for the near future to actually be able to extract these data for Africa. So I did my feature request, hoping that this becomes global because it's just perfect for this kind of EUDR work, just being able to extract that. And there's an API, so I love that. So this just relating back to the beginning of the conference, we were talking about, getting from analysis-ready data to policy-ready data. And so that, in my case, would really help me because, I have a lot of work just working on the wet lab parts, getting the samples, and then relating it back. If it's already policy-ready, that's perfect. And then with Johannes, we were having this discussion of going from policy-ready really to forensic-ready, which is also very relevant for the work I'm doing because this is going to courts, this kind of EUDR, it will have implications, big importers, if they're committing fraud, they will, of course, try to say that our methodology is not sufficiently scientific or there's issues with it. So we really have to reflect, how do we do each step so that it can be valid used as evidence in court. So I was also very grateful for the opportunity of discussing this here. I'm actually going to Living Data in Colombia. If anybody is there, there will be a session on using biodiversity analysis for forensic use, actually. So the takeaway, many steps, issues, producing in situ data, and linking that to global Earth and observation data, but it's simply, we need to do it, basically. So this project, don't do it alone, of course, especially with Victor de Klerk, but there's many at Mace Botanic Garden helping to realize this, and also from Ghent University, Pascal Boeks and Pieter Vermeer. So he works on the isotopes and Pieter on ICP-MS, still in other analysis methods. I'm also very grateful for the interns that helped this year in making our standard operating protocols and using the machines. And of course, funding sources that were more related to the biodiversity work I'm also doing at the garden, but they also helped in building up the infrastructure we're currently using for this project. And of course, thank you for your attention, and I'm happy to receive questions.
Well, it's a great thing that you came to this conference, and you know, we are a bit new to these things you're doing, but we do see there is quite some common interest, right? And also we do work with the spectroscopy, and reminds me a lot now this forensics you're doing a bit like we had with soil spectroscopy. We had a project called Open Soil Spectral Library, and then we were also looking at getting a very small instruments like handheld spectral scanner that if you scan it, you can get a mineral composition, and then you have a GPS, you geolocate it. But let's see the audience question. Greg, please.
Hi, thanks, Christophe. So quite interesting. On one side, I'm still a bit skeptical on how you would go really to remote sensing from this. Partly, but even before there, partly I was wondering, could you tell us a bit more when you have your spectral, when you like the composition of all these minerals? How much variability do you expect per mineral, per sample, per crop? I mean, I don't know. Because you showed one there, and I wonder how much are we talking about? Do we even know? And
quick answer, I don't know, but perfect question, because that's what I want to share here. You know, it's really, I mean, to give you the timeline, this summer we just optimized our standard operating protocols to be able to get a sufficient recovery from a certified reference material, right? This is the stage that we're at. So we're starting this initial analysis to test the variability. One was now that I shared with the roasting, and we already see that variability, that we expect a consistent difference, and we kind of see it across the elements, but then depending on the element, there's a lot of variability where it's not following the trend that you would expect. Between different species, right? We also started just sampling in our garden different types of species, because every species will take up nutrients in a different way, and the trace elements might be introduced in a different way depending on how easily it evaporates, things like this. So we expect so much variation, and so that's why we need to do so many measurements. But then also we're limited. We can do around 24 samples a day. So now we're getting just up to speed to get this to process, and now we need to expand across all different dimensions of variability and assess how much impact it has and how much we can then trust the signal. So yes.
And how long do you think you're gonna have? I mean, in how long of work time do you think you're gonna get something workable?
So the good thing is that we're not by ourselves on this, and it's all thanks to World Forest ID and Victor de Klerk that came to the garden, and Victor's basically working in the garden now, but still for World Forest ID, and they have this global mission, and they work with laboratories across the world. So it's not something that one laboratory can start to assess. We do this exercise in really getting to know the methodology, but also, yes, getting this validated samples from across the world. That's really something that they focus on. And we talked also to Robert about this, right? It can help them to validate certain things as well. Yeah.
Maybe I also, one more thing just pop up on my mind is this SEP analysis. From the plant, you can extract it's kind of like a blood of a plant, and then you can do also mineralogy of that fluid, and that tells you actually what they got from the soil. Then you have the soil, the plant, and
yeah, excellent.
You could also then just based on this SEP analysis. I know we have project also with human health, right? And they have blood samples, and I mean they can do a DNA analysis and just based on a blood sample, they could also even predict where does the blood sample come from. You know, it's scary today because the DNA databases of the people now are getting bigger and bigger, and they can really just based on DNA analysis say, yeah, this blood sample is, origin probably this country, or so maybe this SEP analysis could also.
Yeah, these are all things from a research perspective that are very interesting and also helping us to see what happens at the different steps and to be able to model this, right? Because ideally, I want to start from the soil DB, get those minerals that are present, and then transform this with a model to know, okay, that's what's present in the soil and extractable. And then based on our scientific work, we know it will be modified like this, and we would expect this signal in crops coming from that region. So yes, so good tip, thanks.
There is also the, now I'm just digging in my mind something I read, very interesting article. They have a new type of a barcode for all the products. I'm not sure what's the name, but the simple barcode was just some number, and it will just help you find it back in that shop, where they sell. But they had a new barcode for the products where you can put like almost, you can put so much information in it. So you can really, like if you are a producer, you want to say, I produce it like this, and this, and I use these techniques, and I work on soil health, I don't know, and I have a certificate on organic farming, I don't know. And so when you go to future consumers, like I'm talking like from next year or something, when they go to shop, you could go with your phone and you don't just look at the product, but you scan that barcode, and then it tells you where, the story of the product and of the people they made it, because that's how we should be go shopping.
Yes.
We shouldn't be go shopping like just give me the cheapest, because we need to change this consciousness. Everybody has to change to environmental consciousness and to some kind of a global social intelligence, and they should really understand. We should teach our children to understand everything. If you buy a chicken in the shop, this is not from a printer or something. It's an actual farm that made this, and how they did it and what's their footprint, and you should be aware of all this stuff, because this is politics. This is what we eat, what we buy in the shop. We impact the economy, we impact the politics. If you are frustrated with impacting parties, that you do a party that you vote doesn't win the election, then you should go, when you go shopping, how you spend your money this is how the world turns, right? That's how capitalism works.
Yeah.
If you go in cinema and you watch, I don't know, Matrix 4, they're going to make Matrix 5. So if you don't want Matrix 5, please stop making new Matrix movies. Just don't go and watch Matrix 4, and they won't make Matrix 5, So we need to switch to that, right? And do you know this barcode I'm talking about?
Yeah, yes,
Anyone?
yes. I've heard about it as well, and that's from Europe. Actually, they're pushing to get more information out. And if we're having to do this analysis on the imported goods anyway, they can then also include it. Also for food safety, we also get information on cadmium and health posing risks. So that you do the analysis, you get them all the information. If there's more magnesium in there, that can also be a health boost. So just give all the information to the end user.
Yes. So I like your passion. Just want to say, I like your really passion. I like that you tell a story about, you say, I'm a coffee drinker, and I go and, and observe, and I memorize it. And I hope it will become a culture that what we put in our mouth, what we consume, that we should be aware. Where does it come from? Who made this? Who are the people doing that? Not that you have to become like a PhD in that, but that you can have with your phone, that you come to a product and you understand where does the product come from? What's the story? Any more questions, or we stop for the coffee break? Okay, so we have a coffee break, right? Come back 11. There's an interesting workshop by Yufeng. You will get some hands-on workshop here. So looking forward to that. So please come 11 o'clock, come back here.
Thank you.